Alright, in this video, I will show you how to solve this problem. Assume the input to the analog channel is from an LM35DZ analog temperature sensor. The sensor's output characteristic is 10 milliwatt per degree Celsius with a gain of 25. It means that it has a gain of amplifier amplified by 25. That means the input 10 milliwatt, so the output become 250 milliwatt per degree Celsius. Emulate the presets. So the preset is on the board, on the Arduino multi-learning multi-function board, which is a blue color one connected to GPIO A0. It is presenting the sensor using the provided signal conditioning circuit. So assuming that the gain, the signal conditioning circuit is an amplifier, positive with the positive gain of 35. Write a program to display the current temperature on a multi-7 segment display. So multi-7 segment display still on the Arduino multi-functions board. Okay, right. So the first note, utilize the timer in time-based mode to multiplex the 7 segment display. So we will running the multiplexings by the timer later. I will show you it, right? Then in the from the formula, signal step resolutions SR is equal to B ref positive minus B ref negative over 2 power of n minus 1. Remember, n is number of bits, so I'm going to use 10 bits in this problem. So B ref positive is 3.3 volts and the B ref negative is 0 divided by 1023, right? 2 power of 10 minus 1, 1023. So resulting is about 3.22568.065, okay, volt per step. And then V analog is equal to V digital multiply with SR, step resolution, plus V ref positive. So this is equal to V digital multiply with 0.0322 at 506. Right, so when we convert it to temperature, remember the output characteristic is 10 milliwatt per degree Celsius with a gain of 25. That means now it changed to 250 milliwatt per degree Celsius. So V analog over 25 multiplied by 10 milliwatt degree Celsius. So we can convert it become V digital multiplied with analog change to V digital dot 0.0032258065 over 0.25 multiply equal to V digital multiplied with 0.012903222581 degrees Celsius. So that is the final formula that we're going to inject into our code later. Alright, so go to our projects. First thing first, because it's involved in the timer and something else like the ADC. So we need to set the frequency first. So for the frequency, remember that our analog, if I know analog, I forgot where it is, but for the timer 10, it is connected to FPV2, right? The timer 11, FPV2. So say I set to 60 meg. So remember that our FPV2 timer clock here is 60, right? 60. So later we will work with, oh no, for our analog it is up to 84 meg and 84 meg. No problem. We have the formula that to show it later. Alright, next we go to the pinout configurations. Maybe we can start with the timer. I start with the timer 11. I activate it. This is for to control the multiplexer. Alright, then we go to the timer. Then we go to the timer. Worksheets, in nuclear pin and peripherals. You see from the formula here, time delay is equal to PS blah blah blah. Alright, we're going to multiplex four segments, and each segment we need to So all the segment need to be refreshed at 60 frames per second. So the total is equal to 4 multiplied with 260. So it's 240. So if we invert it, 1 over 240 is about 4 milliseconds. So we can set it to 4 milliseconds, for example, here. So I set to 4 milliseconds, IPBX to 60 max. So if prescaler is 60, divisor is 1, then PR is 4, enough, right? So now I set it to 6,000, right? Prescaler, right? So PR is 40. So from there, I got that 4 milliseconds. All right, so we go to the TS, move this one after we activate it. All right, so we go to the prescaler. The prescaler is 6,000. 1, 2, 2, 3, minus 1. Then for the counter period, if I know second is 40, right? 40. So check, set it to 40 minus 1. For this one, set to no division, right? No divisions, and then enable it because we're going to use it in interrupt mode. So we can enable it now, the interrupt. So that's all for the timer. All right, next we go to the our multi-segments, multi-segments. So our multi-segment is in the APBP. Right. Right, this is the ones. Then, okay, remember, this is a pin 1, 2, 3. This is connected to PA8, PA9, and PB5. So we go to PA8, one set to output. A bit slower. PA9, and then PB5. And then PB5. Alright, all that must be in push-pull. So by default, it is push-pull. If you want to show or indicate that your code is running, then you can set PA5, right, to output. So later you can see your D1, your D1 here, right? Yeah. Let 1, PA5, D3, D13 here, toggling, right? Maybe we can toggle it, right? All others, no need, because we're not going to use it. If you want to compare, say, with the real analog, right? Analog channel, okay? What's inside the analog channel? You can publish it to your serial port, and at the same time, then you publish it to your 7 segment, so you can see the difference between them. Okay, so that one you need the connectivity. You need the USAT2, then you can up. But no, I'm not going to show you that. Okay, go to the analog ADC. So we're going to use AN0. Okay, click in 0. So now this one we change to green color, ADC in 0. We're going to set it into interrupt mode. So what we can do, so the first one should be independent mode because this is the only mode that we do have. Clock prescaler, okay. This one we need to check. Check ADC. I think ADC is here. Alright. So yeah, this is the so what is the time, the conversion time required for that, for example here, I assume it is at 10 microsecond. Okay, say at 10 microsecond, or we can set it to 20 microsecond, up to you. Okay, check it to 20 microsecond, for example. Yeah, 20 microsecond. Okay, so we can play around with the, okay, this one we not use for time being. All right, so the PC clock, the PC clock is here. Is the one shift clock. Yeah, this one, the PC clock. PC clock is 84, no, sorry, 60 meg, 60 meg. This PC clock. So 60 meg, 60 exponent 6. Then devices up to you. You can increase your device by 8, for example, or you can reduce it to 2, or no. Right? You can, that's device depends on you. But I'm going to use 8, for example, here now. Okay? So the FADC is 75, 7.5 micro, right? You divide by 8, okay? This one. And then the resolution is 8, right? The resolution is 8. I want to change it to 10, right? So the T sampling is 137, 137. Okay, remember that, 137. Okay, next we go back to the ADC. So this one should be divided by 8 because we use here by 8, right? Divided by 8. Next, we go to the 12 bits, change to 10 bits, right alignment, of course. Right alignment. Scan disable because a single. Continuous disable. Continuous also disable because we are not using DMA. And or conversion flag at the end of single channel conversions, of course. Then number of conversion is 1. Yes, correct. Right. 1 only. Then regular conversion launched by software. Yeah, we're going to launch it by software, not by timer. And then the rank. Rank we have 1, the first one. Channel 0. So this must be 137. So greater than that, 144 cycle. Right. That's all. 1, 2, 3, 4. Then we click to NBIC, enable it. Right. Then we can generate it. Right. Then we can generate it. Okay, that's all. 1, 2, 3, 4. Okay, that's all I think. Then you can generate it. Okay, when you generate it, then you need to prepare a code that that we require for these applications, right? So first of all, I will solve this the display of the signal, right? Of the temperature, right? Of the temperature. All right. So the first we need the driver, of course. We're not going to start it all over. So go to the exercise, no exercise. Go to the okay, we go to the right. Go to the driver. It's a STM-F401 RE driver. Okay, so this is driver. All right, next, copy all the things that we need. So we need the multi-learning, and then we need the user tick. Yeah, that's 2 only we need, I think. Yeah. Then we can press Control and move it to the include, and then move all.c to the source. It's already Maghrib here. Okay, that's all. Then after that, okay, for the we include them to our project. Go to the include. Found inc include. Yeah, user tick. Enter. Found inc include control space double quote multi-segment multi-learning. We include all of them. Okay. So right now, I'm going to make use of the or setup the timer first. So before that, I'm going to use the view code from the multi-learning segment. I'm going to display the code, the display, the display, right? The segment. All right, so on off, go to space. So I want to on all them on segment. Okay, so I'm going to on all the segment 1, 2, 3, and 4. Right, then maybe I can try with something later. That's okay, no problem. Then I'm start to use the timer. So HAL underscore team base start IT. So the handler is HT11. That's all. Then later, okay, I'm going to include the callback, callback from the driver, from the STM period elapse. So open it up, then go to window, and then show view, then go to outline. It is about 5,000, 5,000 pages, 4,000. Period elapse. Find out. Yeah, this one. Copy this one. Right, copy. Then we go to the main. Then I just place it here. Just place it here. Right, enter. That's all. So the one that I need to call is the multiplex segment. So you can copy this one, or you can write down here. Okay, multiplex segment. If it's better if you can write down something like if esteem instance is equal team 11, right? Team 11. Then you call that multiplex segment, because maybe later you will include another timer in your applications. All right. So that's all for that. Now we start to work with our ADC. Right? Start to work with our ADC. So when we use ADC, first thing first is we need to call that ADC or start the ADC. So we need the user tick, right? User tick. Sorry, we need to set sysdig. Say now I'm going to use say 1, right? 2 for example. Okay, so each time out, say if get sysdig Sam, the first segment, I use the first segment or first sysdig, each say 100 millisecond, right? So 100 millisecond, then I will start the ADC. So we can type HAL underscore ADC underscore start. So we start in IT. Formula is ADC1. That's all. So each 100 millisecond, it will start. Then again, still we need to have a convert complete, right? So that one is just click or open up the ADC.c, and then you can go to window and outline it, or you can find out straight from here. Convert complete, yeah, this one, convert complete callback. Copy that one. Then we can place it here. So this is the callback, or in other words, it is the interrupt service routine for the ADC, as just like the STM period elapse callback. That one also the interrupt service routine for timer. So each time the timer out 4 milliseconds, then we call that multiplex segment, right? And then this HAL ADC is each time it is converted, right? Ready, the data ready, then we can get the data when we can display. Okay, because we're going to display it, right? Uh, we can call it directly from our HAL ADC. We can call it from our HAL ADC. Okay, right. So say I want to call it directly from our HAL ADC. Then it's simple. So I have your INT 16, for example, right? Why you INT 16? Because I use 10 bit. So the digital value is equal to HAL underscore ADC underscore get value. Right? So we have that get value, right? Ampersand HADC1, right? So the value, now we get into the data value. Then we make use of this formula, right? We have the VDTL now. We're going to multiply with this, right? Oh, sorry, we're going to multiply with this, right? To get the degree Celsius. So I can do it directly here. So maybe I need, okay, once I get the value, then better for me to stop the ADC. Stop the ADC. Why stop? To preserve the power. You can let it on, up to you. Okay, then after that, then we convert it double. For example, we use double, right? So the temperature, right? Temperature, temp, 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 Hubble, Hubble, suhu is equal, right? Whatever they read from that data value, right? Data value multiply with this value. Okay, so now we get it. Okay, convert. Then this one need to be double, right? Double. Why double? Because of uh, the data value is in int, else we got 0 for your result. That's wrong. So this now need to be pushed into the 7 segment. So we have a 7 segment here. Okay. Yeah, we need to push it to the convert to number 2 7 segment, right? So I push it to the segment. So convert that suhu, right? But we need to type define it again to UINT 16, right? To UINT 16. Why? Because this convert to 7 segment, you see here it should be the parameter should be UINT 16. Right, that's all the code. And okay. So you gain the code, right? Simple. On off, blah 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 blah. But in our case now, it's saying that okay, this is yeah, okay, it's okay, nothing, yeah. But if we have that point number, we need to multiply it by 10, multiply it by 10, multiply it by 10. So we can multiply it by 10 if you do like, right? So simply you can change this one a bit. Okay, I copy this one and place it here, right? So now instead of the answer is say 99 degree, right? 99 degree, but we can get 99 point something degree by changing this one a bit, right? Take out this one, so we multiply by 100. Okay, it means that in our 7 segment now we have the the first and the second. Okay, so now we go to the multi-segment dot C. Okay, you see we have, this is the first segment that we have here. We have the segments. Okay, this is the segment. So we have 4 segments here. 1, 2, 3, 4. Right. This is the 4th segment. Right. The 4th segment. So the first segment, say now the result is 0.99.5. So the point must be at the third segment. 1, 2, 3. The third segment, right? So the third segment will be the case number 2. Okay, right. So what you can do, you copy this one first, right? So you say that if that I is equal to 2, 0, 1, 2, right? 2. Then you can see that buffer I is equal to num, see to the left I, or with blah blah blah, right? And then ending with, okay, the first segment 0x8000, right? The first bit on the left, and then you invert it. Tidal, right? Tidal it. Okay. Else, that means other than 2, then there is no dot, right? The dot must be 0, right? Because we are using the right active flow, and this is dot, right? The dot. If I place here 0, so you see it is on, right? So now I want to put the third one. So we have 1, 2. Okay, this one. Say now the result is say 0. Okay. Okay, 0, 9, say 9. 0, 9, okay. 95, okay, 95, 0, 95 point. Okay, we want point number here, right? So point number, say 0.5, say 0.5, 0.6, yeah, 0.6. So this what we see later, right? We see 095.6. Okay, that's all the code, I think. Okay, so the change here, don't forget, please remember the changes here, the first change that I did, right? And then you can go to the main, right? Code is very simple, it's nothing. And then convert number to 7 segment to who, right? That's all, right? So what we're doing here, we need to display it to so we have suhu here, right? Suhu here. I would recommend you to change that suhu, right? Suhu, right? Don't put it here, but put it as global, because we're going to use it here, right? We're going to use it here, right? Later, right? I'll show you later. All right. So what we do, you just put it here on top, or you can put it on top of this, up to you, right? So we have suhu, or this much more better. It's better if you can put it here, right? So started with 0, right? Started with 0. So now no need here, this one. Okay, so you can multiply it directly. Okay, remember this one I have already moved it a digit by 10. I multiply it. Instead of 0.0129, I multiply with 0.129. And remember to typecast the data value into double, again suhu into your INT16. That's all. Oh, you can convert it, copy this one and place it here, right? Okay, so once started, so you can see that. Okay, and finally we're going to say if to display or to toggle our LED num1 LED, we're going to toggle each 200 or 300 milliseconds, for example, right? So we can type HAL underscore GPIO underscore D toggle GPIO A pin underscore 5. That's all. So I show you for the last time. Okay, open starting here in the main, we set of course, we need to set the segment for display, right? Then we convert the number to 7 segment, right? And then display what number is inside suhu. So suhu is set with 0. Then after that we set our statistic used to. Oh, you can start your timer, right? Start your timer. So the timer is being used to multiplex the 7 segment. Later I will see you the code. And then while in one, first thing first, it will each 100 millisecond, then it will trigger the ADC. Start the ADC, and then each 300 millisecond, then it will toggle the LED, right? So we use two segment, take statistic or segment here, two. Then after that, in the halting period elapsed callback, then if that is from trigger from timer 11, so we may multiplex the segment. Else, if that callback is from ADC, so we get the value, the present value, and feed it into our digital value, stop the ADC, and then multiply it, right, with this formula, right, this formula. But basically this formula is only without means the without multiply with 10, the temperature is the real temperature, the present temperature. For example, we have 10 degrees Celsius, so the result is 10.5, for example, 10.5. But this one I put another 10, so multiply another 10. So example, our temperature should be 10.52. Then I got 105.2 because we cannot display that 0.2, right? And then we update it, right? We update that suhu to by calling convert number to 7 segment. Remember that, okay? And we place that suhu as the global, because we use it in complete callback and also in the main. Okay, for the right, so and then in the multi-level 7 segments, right? Last, we need to discard the leading 0. We don't want to display, for example, here 095.5.6. We don't want to display this. So this all become we not display for this case. You say for this case of, okay, we don't want to display it. But if we have, say, 195, all right, 195, then we want it to be displayed, for example. Or for example, we have only 5 degrees Celsius, so we don't want to display 5.6. This, okay, so this is what we call as leading 0. So what we do, Control 7 at line number 34, define display leading 0. That's all. Bye bye.